Hello everyone. Welcome to your lesson on subtracting rational numbers. This is lesson 1.5. Your learning target is to be able to find the difference of rational numbers and find distances between numbers on a number line. And your success criteria states that I can explain how to model subtraction on subtraction of rational numbers on a number line. I can find differences of rational numbers by reasoning about absolute value, as we've done in the past. And I can find distances between numbers on a number line, and that's another one where we've worked on that already in the past. So just a quick review here. Remember that if you see just a plus sign on a number line, that means to go right. A minus sign means to go left. Anytime we see a minus minus, that means go left and then turn around, which ultimately means we're going right. So a minus minus actually just means addition, and that would be a situation of a chop chop. So if we have a minus minus like that, we actually use our karate math to chop chop, and that's why it turns into a plus. If we have a plus plus right from the get-go, that means go right and keep going right. So that's obviously just addition. And then when we have a minus plus or a plus minus, both of those ultimately tell us to go left. So ultimately tell us that it is subtraction. So that's just a review of our sign rules. This key idea is similar to your key idea from lesson 1.4 for subtracting integers. To subtract rational numbers, we use the same rule. And that rule was to make everything addition. Again, how we do that is if we have a minus minus, we do chop chop. If we just have a minus, we do chop slash. So we turn every subtraction problem into an addition problem. So let's take a look at what that looks like. These problems today are going to look very similar to previous, but now we're going to have rational numbers, meaning fractions and decimals, instead of just whole number integers. Right, so first step is to turn this into an improper fraction. So 4 times 7 is 28, and one more is 29. So we have negative 29 sevenths. And then we have 5 sevenths. We're subtracting. So thinking about our karate math and turning this into an addition problem, we're going to use chop slash. From there, I hope you notice that both of our rational numbers are negative. We're adding them, so we have negatives plus more negatives. Altogether, we're going to have 34 negatives over 7. Or you could say that this is 4 and 6 sevenths, and it's negative. So for this example, I notice that I have mixed numbers, so I'll go ahead and change those right off the bat. 2 times 2 is 4, plus 1 more is 5, minus negative, and then 1 times 3 is 3, plus 2 more is 5. Next thing I notice is I have a minus minus in the middle, so I can turn that to an addition problem by doing chop chop. And I can find common denominators, which will be 6. Two times 3 is 6, so 5 times 3 is 15. On the right side, 3 times 2 is 6, so 5 times 2 is 10. I have different signs. So when I have different signs, I look for absolute value. The absolute value of negative 15/6 is greater, so that tells me my answer is going to be negative. My denominator is going to stay 6, and my numerator is found by just subtracting the two numerators, so 5. So negative 5/6. For this example, I start out with negative 1/3 minus 1 2/5, so I'll change 1 2/5 into an improper fraction by multiplying 1 times 5 is 5, plus 2 more is 7. To change this to an addition problem, I'll chop slash, and then I'll rewrite both fractions with common denominators of 15. 3 times 5 is 15, so 1 times 5 is 5. 5 times 3 is 15, so 7 times 3 is 21. And in this situation, it's different than the last. I notice both of my rational numbers are negative, so my answer is going to be negative. 15 stays my denominator, and my numerators just get combined. 21 plus 5 is 26. Or I could write it as 1 and 11/15. And that would be negative 1 and 11/15, or negative 26/15. Now you try it. Go ahead and attempt all three of these, and then once you're ready, push play. I'll talk you through the answers. For question number 1, I'm going to chop. So this just becomes 1/3 plus 1/3, which is 2/3. For number 2, I do need to convert. 3 times 3 is 9, plus 1 more is 10. So that's negative 10/3 minus 2/3. I want to change this to an addition problem, so I'll chop slash. And now you'll notice both of my rational numbers are negative with common denominators of 3. So I can keep that common denominator of 3. Both rational numbers were negative, so I know my answer will be negative. And I'll just add the numerators. 10 plus 2 is 12. So negative 12/3 is also the same as negative 4, because 12 divided by 3 is 4. And for the last one, we need to start by writing the whole number 4 as a fraction, and we need to convert 5½ into an improper fraction. So 5 times 2 is 10, plus 1 more is 11. So we have 4/1 minus 11/2. I want to change it to an addition, so I'm going to chop slash, and then I need to rewrite this with a common denominator of 2. 1 times 2 is 2, so 4 times 2 is 8. So I have 8/2 plus negative 11/2. Signs are different, so I look for their absolute values, and negative 11/2 is a greater absolute value, so I know my answer will be negative. My denominator will stay 2, and 11 minus 8 is 3. So I get negative 3/2. Now we move into a different type of rational numbers, being decimals. Remember, decimals as rational numbers must terminate, like in this case, 2.4 and 5.6, or they must be repeating. There must be a pattern. For this example, we're going to chop slash. So we'll have 2.4 plus negative 5.6. We look for absolute values to determine whether our answer will be positive or negative. Negative 5.6 has a greater absolute value, so I know my answer is going to be negative. And then I just take 5.6 minus 2.4, and I get 3.2. So this being negative would be negative 3.2. For this next example, I'm going to chop slash again, and again, both of my decimals are going to have different signs, so I look for absolute values of both. 4.9 in this case has a greater absolute value, so my answer will be positive, and I'll do 4.9 minus 1.6, and I get positive 3.3. For this example, I have minus minus, so I'm going to chop chop. My signs are different, so I look for absolute values. 3.4 has a greater absolute value, so I know my answer will be positive. So I'm going to take 3.4 minus 0.12. A little bit trickier here for subtracting. I need to annex in a 0, and I need to borrow. 10 minus 2 is 8. 3 minus 1 is 2. So I get positive 3.28. And then we'll finish it off here with one last example for this section. I notice that I have a minus minus, so to turn it into an addition problem, I will chop chop. My signs are different once again. So I look for absolute value. Absolute value of 1.5 is larger, so my answer is going to be positive. And I do 1.5 minus 0.75. Annex is 0. Borrow. 10 minus 5 is 5. 4 minus 7 I can't do, so I'll have to borrow again. 14 minus 7 is 7. So I get 0.75, and that stays positive. And now it is your turn again. So find the difference between these three rational numbers as decimals. And then when you're ready, go ahead, hit that play button again, and I'll talk you through them all. So for the first one, I'm going to chop slash to turn this into an addition problem. I notice that both of my rational numbers are negatives, so I know my answer is going to be negative. And I'm just going to add 2.1 plus 3.9, and I get 6.0, and that's negative. For number 5, to turn it into an addition problem, I'm going to chop chop. I notice that I have different signs. However, I also notice that they're the same number. So I have negative 8.8 and I have positive 8.8. In this situation, those are opposites, so they'll cancel each other out, and I just have 0. And then for the last one, I'm going to chop chop to turn this into an addition problem, and that just becomes 0.45 plus 0.05. So I can rewrite this vertically. Everything's positive, so it's just 0.50. Now let's quickly review our properties of addition. Commutative property means that you can add in any order, so 2 plus 4 is the same as 4 plus 2. The associative property tells us that you can group the numbers in any combination. So you could do 3 plus 4 first and get 7, and then you could add 1 to get 8. Or you could do 1 plus 3 first to get 4, and 4 plus 4 is 8. And finally, the identity property, it just means that any number plus 0 is that number. So now let's use properties of addition to make our lives a little bit easier when we're solving big problems like this. First thing I notice, I have a couple fractions here that already have common denominators of 8. I think the first thing that I want to do, though, is I want to change these to have improper fractions, and then I also want to turn this into addition, if possible. So I'm going to rewrite the whole thing. I'm going to go negative 1 times 8 is 8 plus 3 is 11. So negative 11 eighths. I'm going to do chop slash, so I'm going to do plus negative. And then I'm going to do 8 times 2 is 16 plus 1 more, so that's going to be 17 halves. And now I see negative negative, so I'm going to chop chop, and I'm going to turn that into addition. 6 times 8 is 48, plus 7 more is 55 eighths. So then here's where our properties come in. I notice that I have two of my rational numbers that already have a common denominator of 8. So I just want to combine those first. So I want to take this, and I want to combine those. And I can because of the commutative property of addition. It says that I can just rewrite this as negative 11/8 plus 55/8 plus negative 17/2. So let's just look at this part. Negative 11 plus 55. We would take absolute value of both. Absolute value of 55/8 is greater, so I know my answer is going to be positive. I know my denominator stays as 8, and 55 minus 11 is 44. Then I can add the negative 17/2 to that. And at this point in time, we have a couple options. I would say that simplifying 44/8 is actually going to be easier because we could take 44/8 and we could divide by 4/4 and get 11/2. And then if we come in here and we rewrite that as an equivalent fraction, 11/2, now we have our common denominators and we're right back to where we need to be. We have different signs. We notice that 17/2 has a greater absolute value, so we know our answer is going to be negative. And 17 minus 11 is 6. Negative 6/2 is negative 3. Looking at this example, let's think about what numbers we could rearrange if we wanted to make our lives easier and be able to do more mental math. And before we do that, we have to turn everything into an addition problem. We can use our karate math to chop those. We can chop those, and we can actually chop those. So everything here is now addition. And what I notice is I want to put the 0.25 with the 0.75 because I know that 0.25 plus 0.75, that's mental math, and that is 1. I also want to put the 0.38 and the 0.12 together because I know that 0.38 plus 0.12 is 0.50. So I could rewrite this as 0.25 plus 0.75, and that is equal to 1. Then I could add 0.38 plus 0.12 because that is equal to 0.5. 1 plus 0.5 is 1.5. And our last example before some try-its, let's turn everything into addition. So we can chop slash, we can chop, and we already have addition there with 0.9 plus 3.6. So now, as I look at this, I think I would want to take the 7.1 and I would want to combine that with the plus 0.9. So I'm going to rewrite this as 7.1 plus 0.9, and that is 8. Then I'm going to add the negative 3.6 plus 3.6. So I'll take this and add it to that. We're using commutative property of addition to move the numbers around. And now we see that we have opposites here, and negative 3.6 plus 3.6 is 0. 8 plus 0 is 8. After those examples, you try it now. Evaluate the expression, and then write the fractions in simplest form for number 7. So for number 7, first thing that I see is I have minus in there. So I'm gonna chop slash. Next thing I see, 2 of my fractions have a common denominator of 5. I think I want to combine those first. So I'm going to rewrite this as negative 2/5 plus 1 3/5, and then the minus 2. I'm going to convert this to an improper fraction, so it'll be negative 2/5 plus 1 times 5 is 5, and 3 more is 8. And then minus 2. And now I see that I have 2 fractions that have different signs. So I take the absolute value. The absolute value of 8/5 is greater, so I know my answer is going to be positive. 8 minus 2 is 6, so I have positive 6/5 minus 2. The last part of this is I need to write 2 as a fraction, and then I need to rewrite with common denominators. So this is going to be 6/5 minus, and here I'll multiply by 5, so 2 times 5 is 10. And I can chop slash to turn that into a addition problem. Absolute value it again. Negative 10/5 is greater, so I know my answer is going to be negative. 10 minus 6 is 4, with a denominator of 5. And then the last try it for this section is 7.8 minus 3.3, so let's chop slash that, minus negative, so let's chop that, and then plus 4.3. So we can figure out how we want to rearrange this. I think I want to put the 7.8 and the 1.2 together. So 7.8 plus 1.2. I'm going to combine those first because I know that that is just 9. Then I want to add 4.3. And then I want to add negative 3.3. The reason I put them in that order is because I know that 4.3 minus 3.3 is just 1. And 9 plus 1 is 10. Our next key idea is to find the distance between numbers on a number line. The distance between any two numbers on a number line is just the absolute value of the difference of the numbers. So if we want to find the distance between negative 1/3 and 2 on a number line, let's take a look at a number line first. If this is 0, we know negative 2 is going to be over to the left, and negative 1/3 is also going to be to the left of 0. So we're just finding the difference between these two numbers. Essentially, we have negative 1/3 and we have 2, negative 2. And we're subtracting these, finding the difference. So let's first of all write 2 as a fraction, 2 over 1, and then we can chop. Next and last thing to do is find common denominators. That common denominator is going to be 3. We multiplied by 3 to get 1 to 3, so 2 times 3 is 6. We have different signs, so we'll find the absolute values. Absolute value of negative 6/3 is greater, so our answer is going to be negative. And then 6 minus 1 is 5, so negative 5/3 or negative 1 2/3. For this next example, let's find the distance between negative 3.56 and 2.79. And there is another distinct difference here, noticing that negative 3.56 is to the left and 2.79 is to the right. So we want to subtract the absolute values. So we're going to do negative 3.56 and 2.79, and we are going to subtract the absolute values. Or in other words, in this case, because we have minus minus, and because they're on opposite sides of the number line, we will chop chop, which technically just means to add. So we have 3.56 and 2.79. So when we add those together, we get 6.35 in the positive. So now you go ahead and try these. Find the distance between the two numbers on the number line. Hit play when you're ready. For the first one, let's find the difference between 9 and negative 3. Noticing that 9 would be to the right and negative 3 would be to the left. So we have 9 minus negative 3. We chop chop. That's actually telling us that we would add them. So the distance between the two would be 12. For number 10, here both 7.5 negative and 15.3 in negative are going to be to the same side. So we will subtract the absolute values. 15.3 minus 7.5. We'll have to do some borrowing. And we get 7.8. And for number 11, let's first of all change this into an improper fraction. 1 times 2 is 2, plus 1 is 3. So we have 3 halves and negative 2 thirds. Those are going to be on different sides of 0, with negative 2 thirds being to the left and 3 halves being to the right. So when we do 3 halves minus negative 2 thirds, we chop chop. That actually becomes adding. And then we finally just find common denominators. On the left side, we multiply by 3, so 3 times 3 is 9. On the left, or on the right side, we multiply by 2. 2 times 2 is 4, so we end up with 13/6. We'll end this lesson with some real-life modeling. The number line shows the temperature on each side of the James Webb Telescope when in Earth's orbit. Find and interpret the distance between the points. So it says the temperature on the hot side is 185 degrees. Temperature on the cold side is 388 degrees negative. So we know that when we have numbers on opposite sides of 0, we're going to take 185, we're going to take away negative 388, and that tells us to chop chop. So we really just add 388 plus 185. And we get 573 degrees Fahrenheit as the difference in temperature, or the distance between those points. For this example, we dig a little deeper. You withdraw $55 from a bank account to purchase a game, then you make a deposit, and the number line shows the balances of the account after each transaction. Find and interpret the distance between the points. So this is similar. To start out, we're going to take the 6.18 and we're going to take away negative 25.32. Turning it to an addition problem, we're going to chop and do 25.32 plus 6.18. And we get 31.50 as the distance between the 2 points. Now, part B says how much money was in your account before buying the game. We withdrew $55. So 55 is the distance between negative 25.32 and this imaginary number that we don't know way up here. So to find that, all we're going to do is take the $55 that we withdrew and take away the 25.32. So we'll have to do a whole bunch of borrowing. $10 minus 2 is 8. 9 minus 3 is 6. If we have 4, we can't take away 5, so we have to borrow again. 14 minus 5 is 9, and 4 minus 2 is 2. So $29.68 is how much money we started with prior to the $55 withdrawal. Now it's your turn. This is the last part of our lesson. A parasail is 3/100 miles above the water. After 5 minutes, the parasail is 1/50th of a mile above the water. Find and interpret the change in height. Once you're ready, go ahead and push play. So we have 3/100ths, and we're taking away 1/50th. They're both above the water, so both of our numbers are going to be positive. However, we are subtracting. We need a common denominator, which is going to be 100. 50 times 2 is 100, so 1 times 2 is 2. And 3/100ths minus 2/100ths is 1/100th miles.